About 30% of wood fiber Kimberly-Clark uses to produce its tissue products are sourced from Canada and Scandinavia boreal forest. We see increased competition for this wood in the future, and we want to reduce our exposure to natural forest fiber. And one alternative is to look at additional either plantation fibers, recycled fiber, or alternative natural fibers. So bamboo is one of the fibers that we are interested in right now because of the properties it has that we can still make the quality tissue products that we need to make.
我们从2000年开始筹建永裕，到今年为止已经15年，所以说我们从做地板、做家具、做装饰材料和做户外，到我们的全做空间制造者，目前我们的主要产品现在已经在全球已经多有覆盖了在亚洲、在欧洲、在南美，我们有很大的产品已经覆盖全球，所以说这是未来的产业会越来越好，会是一个朝阳的产业。
Even though it's a grass, the fact that you can treat it almost like a wood species, so you can use conventional harvesting technology, you can use conventional logging trucks to move to the mills. It can be chipped like you would a tree, so it's got a lot of favorable aspects.
所以存在一种物种多样性。如果说大面积的发展竹林，可能会对这个生物多样性带来一些这个负面的一些这个影响啊。那么我们呢也不建议就是进行人工化的大规模的来发展这个竹林，最好是根据竹林自身的一种这个扩展特性来让它扩展它的森林面积。
The first step in any sustainability study is really look at the life cycle impacts. Obviously bamboo, because it's a much rapid grower, we're talking about reaching maturity in 3 to 5 years, and then having, annual harvest as compared to a spruce tree, which grows between 50 and 150 years. So there's obviously, land efficiency, the carbon sequestration and those issues, which are the positive side. The invasiveness was an area that was a concern. One of the things we wanted to do was to look at some kind of sustainability standard for alternatives. It's not using more water, it's not using, we're not obviously cutting down natural forests to replace with an alternative crop. We're not displacing food crops, for instance. We don't want to have more pesticide usage or more water usage. So all those things are fed in to the standard.
Some bamboos even, you can just cut off a section and make new roots. The tropical bamboos can do that, and that's a very simple, very inexpensive way to propagate these types of bamboos. But other bamboos have very complicated flowering cycles, and maybe they don't flower for 85 years. In that case, if you have a plantation of this, it's very difficult then to get re-established a new plantation or to start a new plantation, because the availability of the seeds is very limited to that very long flowering cycle. The fact that the seeds have a very short viability, so they don't store well. But now in our new technologies, there's in vitro propagation, which is like a clonal technology, where you're actually taking a very small piece of the plant and making replicas of them, growing them in vitro in a sterile environment, and that way you're mass producing these. The end product is a very expensive little propagule. Some bamboos are proving very difficult to produce in this in vitro way. But if it's very difficult to do or very expensive to do, how can you make that an affordable proposition?
One difficulty with bamboo is it has a high silica content. And so that's a very difficult chemical to get rid of and handle in the craft pulping process. So there are some concerns about how do you get the silica from causing corrosion and other issues in your pulping process. So that's a technical challenge. That has to be fed by the mill. So in terms of, and then once the material's made, then there's no, it's a cellulose fiber, so it's no different than anything else to make a tissue product for us. So we had, the ability to do that. Then it becomes, just basically a cellulose fiber that has the properties we need.